So quick on serverless. To do serverless, I have to talk about the entire history of compute. Gosh, right. So we start off with compute, actually earlier than this, the Z3 1943 really. Applications built straight into hardware, plugs, wires, etc. Then we got systems. This would evolve, supply and demand competition. We start getting custom built systems, things like Leo, Lines Electronic Office. And so what we've now got is applications built with operating systems built with compute, custom built compute. And this would evolve, and then we got wonderful things like this. IBM 650, yay! So now what we've got is applications operating system on compute as a product. Now that was great. Compute as a product had a certain characteristic. It's called high MTTR, mean time to recover. So mean time to recovery is useful in all sorts of different ways, particularly in business, because that's recovery from somebody impacting the environment you're working in. But we won't go into that. What we mean here is that when my machine went bang, it would take me weeks or months to get a new machine. So we built our architectural practices based upon that. So we did scale up, N+1, capacity planning. Anybody remember that sort of stuff? Disaster recovery test? Yeah, good, right, fantastic. This stuff would evolve. A new faction appeared. As it became good architectural practice, we used to run around laughing at people. You hadn't done your capacity planning, you ran out of space on your email server. Anybody remember that? Yes, good, excellent. And then, of course, we've got language frameworks. So now we're applications, emerging coding practice on a framework, on an operating system, on good architectural practice, on compute as a product with high MTTR. That would evolve, and we got to them, we were all happy. And then something evil happened. That evil thing was cloud. This is the entire history of cloud in the diagram. It's that dotted red line at the bottom. It just means that compute went from a product to a utility, basically. But that has a big impact because it changes its characteristic. And what that means is you get what's known as co-evolution of practice, which is one of the things we knew in Ubuntu, that we were going to get a change of practice. We didn't know it was going to be called DevOps, but we knew it would be a new practice. So we go from a high to a low MTTR environment. So rather than weeks, it takes me seconds to get a new machine. So I can now, distributed systems, design for failure, use chaos engines. I can do continuous deployment because I'm not waiting for months for the machine to turn up. I mean, there is no point doing continuous deployment if you are waiting for months. So we got a novel architectural practice, and then of course people got excited by cloud. They're bored of 3D TV or whatever it happens to be. So you get CEOs going, make my stuff cloudy. Usually stick my legacy onto the cloud. Amazon would have an outage, and then people would run around screaming the end of cloud is nigh. To which you would go, shouldn't architecture evolve as well? To which they would go, burn him, heretic, that sort of thing. And that's because best architectural practice for the use of product world created inertia for them to this change. Oh, what do you mean this? Oh, no, we've been doing this stuff for ages. Yes, but in the product world it's changed. But anyway, so you get inertia. So anyway, that evolved, and then what you got is a new faction appearing around those practices. We eventually gave it a flag or a name or whatever you want to call it, DevOps, and they ran around saying things like it's all about user needs, iterative cycles, automation, feedback loops, etc. To which other people would go, hang on, so was ITIL? To which they would go, burn him, heretic. Do you remember those battles? Yes, the complete unreasonableness of it all. So anyway, computes now, obviously went to a utility, operating systems did as well. We're getting the same in the framework, so that's the platform space. Moving to basically a utility. So you've got things like Lambda has all the sort of characteristics of a utility. We're seeing a co-evolution of practice. In this case, that practice is combining finance and development skills together. So it's all about capital flow in applications, completely different to the stuff underneath. So anyway, from this, that's basically the future. That's where we're going. We're getting a new faction appear around there. And all the rest of the stuff is heading towards legacy. So everything below that line. Now when I say that, people go, hang on, you've just said DevOps is the new legacy. And the answer is, yes, it is. It was great, 2009, 2010. If you're kicking off now, whoops. But when I say that, people go, burn him, heresy. Okay. And they tell me containers are the future. So, there's your stack. Everything below that line, operating system, containers, all that sort of stuff, unless you're a provider, doesn't matter. The battle is above there. It's all about code. Code execution environments, simple as that. So the stuff at the bottom we won't care about. You have to move up the stack, but unfortunately there's loads of companies intent on winning the battle at the bottom but losing the war, but you know, that's normal. This process normally takes about 10 to 15 years. We're about 4 years into the battle already. So at that point, I have definitely run out of time. So I'm going to say thank you very much.